Okay, so we are live. We are actually live on both Instagram and Facebook. So, guys, if you're on Instagram, follow me on Facebook. If you're on Facebook, follow me on Instagram. And that is you looking at you. What's up, Y&D Cooling? How you doing? What's up, Don Taylor? What's up? So I put something awesome together for you guys tonight. Woo! Documentation. What do I got here? We're going to talk COP, coefficient of performance. I got really interested to find out how much money does a mini split heat pump cost you if you do your whole house with a variable speed machine instead of going with a hydronic baseboard heating system with a high efficiency boiler. So if you don't know me, my name is Mo. Read it up on my shirt over here. Right over there somewhere. Oh, camera, it's always backwards. Here's Mo. So my name is Mo, and I know a lot of stuff. I know a lot of stuff about a lot of things, but nothing do I know perfectly. I'm always researching. So plumbing, heating, cooling, radiant, combustion, all that stuff. What's up, Mr. Construction? So what we got over here is I took a model house, and I took a model of a 45,000 BTU house, and I broke it down with heating degree days by the month. So used the last year's data, and for this is where I live, this area. So for the month of November, we had 728 degree days. December, 1,126 degree days. January, 1,198, and then we went. February was 836 degree days. March was 895. March is actually colder on an average than February for 2018, that is. And for April, we had 634. So that's basically, we've got 6 months. What's up, Mutty? And I did not include October, and I did not include May. Both of those had roughly 100 degree days per month. And depending on where you live, you may just not run your heat much if you have good insulation. So 45,000 BTUs, use the actual efficiency. 45,000 BTUs is we take a picture of the house, think about a snapshot in time, north wall, south wall, the color of the roof. We take the insulation in the home, take everything into account, how much glass there is, and take that all into account and blow it into a model. So I got 45,000 BTUs. I then went ahead and broke down the coefficient of performance, which is the COP, which I'll get to in a second. I divided up by month, and then I divided up the heating efficiency per month. So coefficient of performance is, if you think, let's talk about a boiler. You have 95% boiler. So take 95%, means for every dollar you spend, 5 cents went up the chimney. Kind of hard to understand the next part, but it is, if you take an electric baseboard, this part's easy. If you put $1 into electric baseboard, you get $1 out. It's 99 point something percent efficient. So if you're going to go ahead and you're going to have a mini split or a Mitsubishi variable frequency drive, what you basically end up with is, on a variable frequency drive, because they use phase change, you end up with something called coefficient of performance. Manufacturers rate them at 4.0 COP, 3.5 COP, et cetera, et cetera. What people don't know is that that rating is good at 47 degrees. And at 47 degrees, you're not really worried about your heating. You're worried about your heating at, as the temperature gets a little colder than that. So I did is I took real life, let me just adjust the light over here for a second. See, is that any better? Well, that's a little better. I don't know. My laptop seems to be shading out half of my face, and my Instagram is doing kind of the other half. But anyway, so what I have at the end of the day over here is coefficient of performance. Coefficient of performance, 350% coefficient of performance, hypothetically. So that means that for every dollar you put in, you get 350% heat. So hypothetically, again, if you're going to put $1 of heat and you're at 3.3 COP, which is 333%, it's going to cost you 33 cents. Pretty sure I got my math right over there. So anyway, what we got next is I broke it down every single day. I took a Mitsubishi MXZ hyperheat machine. So we're capable of running down to at least negative Fahrenheit numbers. And I broke it down by the COP. So at 17 degrees, it's a published rating of 2.5 COP. And at 47 degrees, they have a COP rating of 3.45 COP. So what you end up with there is, I have to interpolate some of the data. So it's close, but not perfectly calculated. At 24 degrees, you get a 2.8 COP. At 30 degrees, I'm just reading off my paper. It's a 3 COP, and at 40 degrees, a 3.25. So at 32-degree day, freezing, good number to choose. 3.0 COP means 300%. Put $1 in, divided by 3. That's how much you're basically getting you're putting 33 cents in, and you're getting $1 worth of electric heat back. So here's where the numbers get interesting. So I went ahead and I calculated the COP over the course of the 6 months, and that brings me to my other paper here. 3OP average over 6 months is 3.1. So you have this machine that's rated at 3.45, and they're giving you an average of 3.1. Now, the boiler, based off of the return water, based off of the supply water, actual calculated information, not seat of the pants, not the rating plate, none of that stuff, actual VSMIN information of what the percentage efficiency rate will be based off of your supply and return water temperatures. Your supply and water temperatures, we ended up with a 92% boiler efficiency over the year. You put in $1, get 92 cents into your house, 8 cents go in the garbage. So that's what you've got. Calculated it all out and crunched some more numbers. So hypothetically, the course of this year, this house that uses 45,000 BTUs, assuming that the windows and doors don't get opened drastically more than what you're actually calculating. Thanks for the thumbs up, guys. By the way, you give me a little wave, give me a little holler, and if you want, you can just DM me or PM me or whatever you want, and I'm more than happy to talk to anybody. So spread this out. Do me a favor, get out there, let everybody know that I do lives, let everybody know about my Instagram, my Facebook, because I just like conversing with people, like helping people out. Anyway, so over the course of the year, if you went with this Mitsubishi machine, the cost of producing the heat, we're not talking about the distribution system, we're not talking about the fans, the pumps, any of that stuff, producing the heat, the Mitsubishi MXZ series with this average 3.1 COP would run you 1,000, ignore my phone, would run you $1,174. We're going to give it a second till my phone stops beeping. There we go, I canceled it. No, they keep on going. Give me a second, guys. Oh, thankfully, it looks like they stopped. Anyway, so it's the guy with a Mitsubishi machine to generate the electric to make that heat for the compressor would cost him $1,174 over the course of the 6 months. That same house with a boiler running water temperatures of a high of 160 on a coldest day of the year would run him $733. Calculate that difference, and here is where things start to get shiny. So you say, oh, dude, it's $300 or whatever. Don't really care about the $300 difference. It's more like $400, whatever. Well, it's 46% difference. So the average person is going to come back to me and say, dude, there is no way that I'm spending $733 on my heating bill for the course of a year. So first of all, negate your stoves, negate your hot water usage, negate your dryers, negate your gas barbecue grill, and you may be only paying $733 if you live in a average colonial or high ranch house that's well insulated or new construction. So $733. If you are paying more, if your heat loss is double that, that just takes your difference. A Mitsubishi machine or other high efficiency heat pump machine claiming those great coefficient of performances, that takes you up to a totally new level. And that takes you to, instead of a $400 difference, now you're talking an $800 difference per season. The larger you get, the 46% is just keeps doubling and doubling and doubling. So what I'm here to tell you is that every application and every product has the correct application. So for some places, it is not necessarily important to go ahead and install a whole heating system, a baseboard heating system, a radiant heating system, a radiator heating system. Sometimes just forced air does make sense. And even when forced air does make sense, you have to see, does producing your heat through electric make sense? Or should you be producing your heat through gas? So when you're building a house, when you're replacing a system, these analytics and these analyses have to be taken into account. And just for like kind of records over here, I was using 23 cents a kilowatt delivered cost, and I was using $1.25 per therm or per CCF delivered cost. So if your cost varies and you get 12 cents per kilowatt, and you're paying 12 cents per kilowatt, and maybe you're paying, instead of $1.25, you're on propane and you're paying roughly I don't know, maybe $3 for the same 100,000 BTUs. So your variable frequency drive VFD mini split may just make sense, may make you break even. And if you need air conditioning anyway, it makes sense. So it really depends where you are, and it comes down to what your fuels available are and did you do an analysis. There's always life cycle costs and a lot of other stuff that have to be calculated into this. But that is just the beginning of the calculation. So if you're interested in getting your house or your building with a full analytics and analysis, a heat loss study, if you're designing a system or you're thinking about a system being designed, you can reach me on Instagram at MosesPNH. You can call me on my work phone at 347-460-4328. That stands for 347-460-HEAT. We deal anywhere in the country. We deal anywhere in the world, actually. We get calls from other countries asking us about on-demand systems for hot water, plumbing, heating, cooling. We can help you out. We do a lot of consulting, a lot of engineering. We do a lot of the work ourselves too, if it's within a drivable, reasonable distance. We are located out in New York, in Pomona, New York. We travel anywhere within a couple hours, so we deal with Pennsylvania, Connecticut, New Jersey, New York, up till the Canadian border and down till just into Philadelphia is north and south. West we go Pittsburgh, Pocono area, and the other way we go to Vermont, a little bit towards the right. Not, we go east. You call us, we'll take care of you. And that's just about it, guys. So if you guys are interested, I'm planning to come out with a little book on a couple steps that you have to know as far as a homeowner, and a couple steps in a different book as far as a builder, what you have to know to build a house properly with a good heating cooling system. It's going to go over life cycle costs. It's going to go over cost of materials, choosing the materials. We're going to go over everything, soup to nuts. So if you guys have any questions, I'm still available now for the next couple minutes. I'm going to stay live, see answer you guys' questions. If you guys, I see we got some questions over here coming in. Okay, so that guy is asking, he says that he's got a forced air and a regular compressor. He's a natural gas. Does it make sense for him to go with a mini split or variable frequency drive ducted system? So when you're going to go ahead and you're going to put a ducted system in, there's one of the biggest one of the shortcomings of a variable frequency drive system is a lack of people who know how to properly fix them. They actually also have a very short life cycle of roughly 10 years. 10 years. The control boards, the compressors. Go ahead and take a look at a 10-year-old system. What's up, Rudy? What's up, Ariel? Talking about some mini splits. You guys left some major data, but we're going to go over it in a minute for everybody who just joined, because we're running Facebook Live and Instagram Live together. So you're going to deal with variable frequency drive, not variable frequency drive, sorry, VFD systems. One of the issues that you're going to get is short life cycle cost. A furnace will generally last a little bit longer, and if you have natural gas, you'll be paying cheaper for the same amount of energy. If you're in an area that does not need primarily cooling and you're in a primarily heated area like up in New York, you only need cooling 3 months a year. Upgrading to a super high efficient air conditioner, you'll never break even. You'll be great for the environment, but it's just going to cost you money. I'm going to go full circle now, and I'm going to bring back all the way to the beginning and let you guys hear what I just explained in the first 15 minutes of this. So we were going over, I modeled a house with a 45,000 BTUs with a Mitsubishi MXZ Hyperheat heat pump. And we went ahead and modeled the same exact house with a baseboard heating panel radiator system with a high efficiency boiler. We used the high efficiency, the percentage we used right out of Viessmann's book, what the efficiency rate is based off of your supply and your water temperatures, and that was mapped off of heating degree days, which I calculated on these two papers for the last 40 minutes, just going through the numbers, seeing which way I could sway it, trying to get the argument or swaying the argument in favor of the variable frequency. I keep saying variable frequency. I'm thinking about pumps today. Instead of the VRF, the variable refrigerant flow. VRV, VRF, all different types of stuff. So anyway, variable refrigerant volumes, they have variable ear volume systems. There's all different types of systems out there in the ear side of things, in the forced air side. So we came out at the end of the year that you'd use 587 therms of natural gas would run you $733 for the season on a 45,000 BTU house. That same exact house would run 5,105 kilowatt at 23 cents a kilowatt would run you $1,174. And just to circle back to everything for the guys that just jumped on our Facebook and our Instagram, is that what you have over here is you have a house that is costing you more money to run on a high efficiency Mitsubishi style machine. And I'm not against machines that are high efficiency or that Mitsubishi and electric. I'm against choosing a product that is not for your application. I have a term, there's no such thing as bad products, just misinstalled and misapplied. So that boils it down, guys. If you guys have any questions, again, I'm coming out with 2 books, one for builders, one for homeowners building houses, and this is going to teach each individual class what they have to know to choose the right type of equipment. I'm always available for consultations. We go out anywhere in the country. We go out anywhere in a driving distance, definitely. So if you guys have any questions, you can reach me on Instagram at MoesPNH. That's MoesPandh. You can reach me on my work phone at 347-460-4328. You can email me at moesplumbingandheating@gmail.com. And I urge you to check out turnupthecomfort.com, where you're going to see a lot of these videos that are live. You're going to see a lot of the other information that I'm putting out there. So guys, I really appreciate you joining. Enjoy your day. I'm signing out.